In this video, the learner will determine the area of a regular polygon using apothem. So let's remind ourselves what the radius and the apothem of a figure are. We're dealing with regular polygons. The radius is the segment from the center to the vertex. The apothem is the segment from the center perpendicular to the side that also bisects the side. Now, so far we've looked at equilateral triangles, squares, and hexagons that all contained special right triangles. Our 30, 60, 90s and our 45, 45, 90 triangles helped us solve for missing information. As we take a look at this pentagon here, could we use a special right triangle to solve for missing information? Well, if we were to solve for the interior angles using our formula, we would find that each angle was 108 degrees. Therefore, when we drew the triangle with our apothem and radius, that radius would cut that 108 in half and create a 54 degree angle at the vertex. So we don't have a special right triangle pattern with a 54 degree angle. So the answer to that question is no. The interior angles of the pentagon are 108, and the triangle created with the radius and the apothem have angles of 54, 36, and 90. So we have to have some other strategy to be able to find missing information. So to solve for missing information, we're going to have to use the trigonometric equations. Just a quick reminder of what those trig equations are. SOHCAHTOA is the acronym for the equations that represent sine equaling opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent equals opposite over adjacent. Also remember, we're taking the sine, cosine, and tangent in reference to some angle of the triangle. So sine of x is the side opposite from x over the hypotenuse. The cosine of angle x is the adjacent side to x and the hypotenuse. The tangent of x is the opposite side from x over the adjacent side to x. So as we take a look at this pentagon here, we want to find the area of it. We're given the apothem, that's 2.1, and we need to find the perimeter to be able to use that formula, 1/2 apothem times perimeter. So what we're going to have to do here is we're going to have to use this little right triangle to be able to solve for this piece here. Remember that the apothem in every regular polygon is a bisector of the side. So if we find this base of this little right triangle, then we can find the side length and then therefore the perimeter. So in this little right triangle we have a 54 degree angle. Like in our previous example, the angles are 108, and then divide that by 2 to get 54 degrees inside this triangle. We're also given the apothem, which is 2.1 inches. We want to solve for this side down here. So from 54, the 2.1 is opposite. The side that we're solving for is adjacent. Opposite and adjacent means we're going to be using tangent. So tangent of 54 degrees equals 2.1 over x is our equation. We would multiply by x and then divide by tangent of 54, and we would get x equals 2.1 divided by tan of 54, which is approximately 1.52 inches. Which means this piece down here is 1.52, but because this apothem bisects the side, this piece over here is also 1.52. When we put these two pieces together, we'll get the side length of 3.04 inches. Then we have a perimeter of 15.2 inches. Now I can plug both of these values into my formula to find area. So 1/2 times 2.1 times 15.2, and the area is approximately 15.96 square inches. In this example, I want you to find the area of this octagon. I'll give you a couple of hints here. Remember how to find the interior angles of a polygon. The formula is 180 times n minus 2 divided by n. When we do that for the octagon, we'll get interior angles of 135 degrees. So if the interior angles are all 135, when we draw this little triangle with the apothem and radius, that 135 degrees will be cut in half to create that 67.5 degree angle. And notice you're given the apothem and need to find the perimeter.